Welcome back to the shop. We're going to get started on our next repair job. So what you have in front of you, we have some parts here out of a grandfather clock that was built in 1895. So this belongs to Mr. Paul, who resides in Georgia. He's a viewer of our channel. Paul reached out to me via email and asked if this was something that I would possibly be interested in helping him with, because he does not have a lathe to do this repair himself. So the problem that we have here is this threaded rod broke. There's your broke in right there, okay? This part of the rod, as he's got it flagged there, goes into this brass block right here. Go ahead and screw that in there. All right, goes into there, okay? And then the other piece of the, I want to be really careful with this stuff because I do not want to do any more damage to these parts. We're talking about parts that are about 128 years old. And I'm very impressed with the quality of the machine work, should I say. And I'm not saying that machinists and craftsmen could not build highly precision or beautiful parts back in those days, but it's just amazing to think that these parts were made 128 years ago. It's very cool. So getting back to the repair, on the other end of the rod there that broke, it actually screws down into this piece here that looks like a bell. It's actually got an etching there. It looks like a mountain. It's pretty cool. So this gets screwed down into this piece here, and then there's a washer that goes on there, and then they have a square nut that goes on there that locks it in place. All right. So that's the problem. This brass rod is broken. And Paul asked if I could machine another one to replace this one. Apparently it got broken in transit, but that's all he told me. I don't know if it's something that he purchased, or maybe he was moving it around or whatever, and it got broke. But you know, that's a very old part that's probably had a lot of fatigue there, and it just finally bit the dust, you know. So let me try to briefly explain to you what the issue with this is. Because of its age, this isn't necessarily a standard size rod, or a standard size thread, should I say. It's not an industry standard size. The thread diameter is 5 millimeter. Now, whenever Paul went up to his Home Depot to check it using some standard grade hardware nuts, and he determined what he thought was a 1224 thread there, because it does screw into a 1224. So once I got it, I went ahead and started doing my inspections on it, and I quickly realized this is not a 1224. Here is a 24 screw pitch gauge, and it does not fit the thread at all, okay? So I said, we got definitely not that size there. So with the diameter being 5 millimeters, so it measures about 204 or so on the diameter, I wasn't really sure what it was, so I went back to my other screw pitch gauge, my metric one, and so for 5 millimeters, it should be either 0.8 or 0.9 thread pitch. Okay, so 0.8 does not fit, 0.9 does not fit. That's kind of throwing me off. So I went up to the next one, 1.0, bam, it fits it, perfect. So that's what we have here. We have an M5 by 1.0, which is not an industry standard size, all right? Which makes a little sense, because if these parts are 128 years old, this was made before all of your common known industrial sizes of hardware were unified, okay? So maybe the clockmaker was using whatever thread pitch that they felt was suited for the job at that point. Maybe people were machining 5 millimeter by 1.0 threads at that time, and then they later standardized them to a 0.8 or 0.9 pitch for 5 millimeter, because 1.0 is actually standard for 6 millimeters. Usually when you see a 6 millimeter bolt, that's what it is, 6 by 1.0. All right, so we got a 5 by 1.0, so that's what we're gonna have to make there. All right, I have got a piece of 544 bronze rod here that we are going to machine into a new threaded rod there. All right, There shouldn't be any problem with leaving the center of this 1/4 inch diameter, because there's nothing here that is affecting it. It's not sliding through anything, and the thread itself is actually going through this piece to the bottom for the nut to go on. So I don't see a reason of having to turn this whole thing down to 5 millimeters. So we'll just set it up in the lathe, and we'll turn and thread both ends for our M5 by 1.0 thread pitch. And since we have this piece and this nut here, we can use these as our thread gauges when we're single pointing it to make sure that it fits right. All right, so we'll head over to the Precision Matthews lathe and see if we can get this little job knocked out for Paul. Just getting a length here on our rod. It looks like it's going to be, put that in there, right at 5 5/16. So we'll just cut us a piece 5 3/8 and face the ends off. That should work fine. Just grinding up a simple turning tool out of a 3/8 square high-speed steel blink. We'll face the ends and drill a very small center hole in them. Adjust our height a little bit there. That's the tip that we're going to put in our center to use to hold it, and it's going to be very close, but it should work. We'll hold it like that. That's why it's really handy to have one of these interchangeable tip centers in your toolbox for doing jobs like this, those small diameters. So just repeat that on that side. This side here, we could technically probably chuck that closer and turn it and thread it, but I feel a little more comfortable having it sticking out since we're going to be doing some metric threads. And the other thing I was going to mention is that both of our diameters on our the old screw right here, when you use a mic, mic out at 0.203 inches. And both of them fit good in the tapped holes. So even though that's slightly larger than 5mm, I'm going to go ahead and match the diameter that they turned it to on this right there. So we'll do an OD of 0.203 with a 1.0 thread pitch. We'll go ahead and, I haven't mic'd it yet, so we'll see, make sure that we are starting on 1/4 inch. Looks like 251 on the mic. So I've got about 50 thousandths to come off. Already got a link set where we need it. That bronze is turning nicely. We'll get you zoomed in there a little closer so you can see that. Come up to our 0. Right there. Matter of fact, I'm going to set this one here also. Where are we at? All right, 213, 10 thousandths. I'd like to put a radiused thread relief there in that shoulder. So I've taken another one of my parting blades right here, high-speed steel parting blades. I reground the end. This was ground on a radius, but it was a little too wide for what we're doing there. So I grounded approximately half this width there, so about a 1/16. I haven't measured it, but we're about half that, and then radius the corners, and that should work to get a nice thread relief in there. I just think that it makes a nicer looking job, and with the radius down in there, it's actually going to provide a stronger joint versus just the thread, you know, the sharp V thread that'll be cut in there. So we'll come up here into the shoulder, and it's going to be right around 40 thousandths deep. That will blend that shoulder in with a nice radius there. Still a little bit too high on our tool there. See if I can drop it down a touch. There we go. Get that corner blended in there. Looks nice. Get a little bit of chamfer on there. All right, we're set up for our first threaded end. We've got my camera up there so you guys can see this a little bit closer. Working on some really small stuff. So what I like to do, and I like to show this to you as well, we're going to be running a slower RPM just because we've got such a tight area to work in. So we are wanting a 1.0 thread pitch. So LCR3Z. LCR3Z. and Z is all the way to the right side right there. So that's why we'll make our scratch pass and verify it before we go any deeper after that. So I am going to be using the method here where I disengage the half nuts. Now, what you have to do is, what we'll do is we'll go ahead and put a dot on one of these numbers right here that we're going to line up on, and that's going to be the number that we have to line up on every time. And what I mean by that is not let it rotate around and line up again. What I mean is whatever you start on, say we started on that 2 right there. Okay, we're cutting. I'm going to stop it with a foot brake right there. Disengage, and we're going to reverse it. Once you disengage it, the machine's going to be rotating. See, it's going to rotate around a little bit more. All right, so what you have to do is keep up with this number. Don't let it, if it goes around, that means you have to reverse it and come back around 1 revolution. So we'll go ahead and reverse it. Engage the half nuts. I'm just going to go ahead and stop it with the foot brake there. As long as you mark your number that you start on and you disengage and you keep up with how many rotations this does, really it's just going to go past it a little bit. Reverse the machine, line up the half nuts on the number again, back to your start point, stop it, reset your cross slide or your compound, whatever you're going to use there, and go in for your next cut. And you keep repeating that, and that is a great way to be able to disengage the half nuts so that you don't have to worry about your tool coming forward and crashing into either your shoulder of your workpiece or even the chuck or something like that. And that's what I try to tell people is that, well, I just keep it engaged all the time. There's plenty of jobs when you're threading it, you can't just let this thing idle down to a stop. Some people don't even have a foot brake to stop it on like older machines, you know. So you want to disengage it so you don't crash into a shoulder. You know, there might be some kind of feature here, a big flange or a big shoulder that you got to go all the way up against to, and you have to disengage it so that you stop the carriage from moving forward. So anyway, that's what we're going to do. Let's go ahead and get started on the threading. Put some blue highlight on here so it's easier to see it. Get our tool touched first and set our zeros. Ready for our scratch pass. I'm going to line up on the number 1. Disengage. We're going to back out, stop the machine. And we want to go in with our screw pitch gauge, checking it with a 1.0. Have to move the tailstock to be able to get it lined up. Okay, that looks right. All right, that's good. I know it's hard for you guys to see that. I'll try to put it around on the side, but that's lined up on 1.0 right there. All right, we'll continue on with our threading now. All right, so we're going to reverse the machine. Gauge the half nuts on number 1. We're going to back up. I'm going to use the foot brake to just stop it right where I want it. And we bring our tool back into our 0. Right there. We'll go in with our compound, about 5 thousandths. And we take and just turn the machine on. Forward direction. It's already engaged. It's that easy. Back out, stop the machine, reverse it. It's nice having that foot brake so you can do that right there. Let's go in with another cut. Forward direction. Nice, easy, controlled movements. Back out. We're going to reverse it, line up this number 1 again. Just like that. I'm watching my tool come back to the front. Stop it with the foot brake. Go into our 0 right there, 0 on X. Let's take another 5 thou cut. We're already engaged, so now we just simply go forward direction. Get to that thread relief, disengage, back out on the cross slide, hit the foot brake, reverse, line up on our number 1 again. Just like that. Pretty easy to do. All right, we got a little bit deeper to go here. And we're just going to go ahead and leave it right where it's at because I want to go ahead and start checking our thread at this point. So we'll back out our center and I'm going to grab one of our test nuts. We'll go ahead and try this guy right here. All right, still a little too tight, so we need to take a little bit more off the thread pitch diameter there. I'm only going to take 2.5 this time here. All right, let's try it again. Still a little tight, so we need to go a little bit further with it. You can hear it's still a little too tight. Need to come down a little bit more. We may have to take a little off that OD. Not sure, but take another little cut. I've only been taking 1 thou at a time right here. Certainly look like more than 1 thou, but let's see how it does. Definitely fitting that good, so I guess we need to, it's still a little bit snug on that. I may need to take a spring pass on that just because you can see it's a little bit tight. This is the rod, this is the end that screws into the block, so I need to make sure that it screws into that as well. Let's make one more pass. I'm hoping that's going to be enough. 1/1000ths on the cross slide here. Let's try it again. That feels good right there. I think we might have it. Here is the square nut. So this first end, I feel like we've got it cut where it needs to be, but I can't take the block and screw it on there because this is in the way. I have to take the rod out and screw it in there. I'm just concerned that it may be a little tight going into this one, but we can line back up on those threads if we need to chase them again. So I'm gonna go ahead and disengage the machine, which we are, but now that I'm backing up, you can see we're rotating around. Once I back out from this thing and I turn this machine on, because I want to do a little bit of filing, I'm losing the place of where I'm at, so I can't go back to this and line up again. You just have to make sure that you come up and line up the tool and verify where you're at on the dial there. I'm trying not to bring the diameter down much. I'm just trying to get rid of any burr or sharpness that's on the top and on the corner right there and on that little chamfer right there. All right, we're taking it out. That means we are definitely not lined up anymore. That is a beautiful looking thread. The rod machined nicely. So let's see. It fit. It fits.
I think you nailed it.
There we go. So one end down. Let's go ahead and cut the other end now. Got about 24 thousandths to come off. We'll bring it down to the 0.203. Landed on 204, 1 thou over, but that's all right. I think we can file the top of the thread when we get to that. So here's a little trick to file this while you're still engaged. So I'm going to go ahead and reverse it, engage the half nuts, and let it back out. And while it's spinning, I use a file. I hold it backwards and just lay it down on the threads. Just like that. And all you got to do is stop the machine, go forward, and bring it right back into where you want to start your cut. I wanted to get a couple thou off of that diameter there. Not quite there yet. You can do that one more time. Just need another thou or maybe two off the thread pitch here. Taking a half a thou on the compound slide per pass here. But what I want to do is just go ahead and check it. Still too tight. Got to get it where it'll screw onto this little bell piece. All right, we're basically there. It's screwing on there, but it's still a little bit tight. So I need to take that same cut there. Let's take a half a thou and see if we can get it from rubbing and squeaking on each other there. And we might have it. Is this going to be the one? That might do it right there. I think it needs another spring pass on there. It's still a little bit tight. You want to be able to screw that in there with your fingers, preferably. But it's still a little bit snug on this guy, but the square nut fits because I've already tried it. So we just got just a little bit. I'm going to say another half a thou, maybe another spring pass, and this is going to be good to go. That's feeling right there. All right, screw that all the way on. The washer that goes on there, and then the square nut goes on the back side of that. Just like that. Well, that is going to complete this repair job for this 128-year-old grandfather clock. So just so you guys are aware, I went ahead and made a second rod there. So you saw me thread this in, and I didn't like the way that it fit in the tapped hole in the brass block there. It was just a little bit more loose than what I was expecting it to be. So I decided to just cut another one and redo it and tighten up the pitch and try to get it a little bit closer, which we did. We got it fit in there really nice. I even like the diameter difference there. It kind of gives it a, it does give it a slight shoulder to screw up against. All right, and then we have this piece here. The flat washer goes on next, and then the square retainer nut. that is it. This little repair job is done. I was happy to be able to help Paul with this project here and help him get this clock back in operation. Pretty simple operation, but as you can see, even having to machine a small part that fits in your hand doesn't necessarily mean that it's any easier to get done than, say, a large part that's going to go in the big American pacemaker. You know, it's all relevant. Small pieces can be just as frustrating to make as you know, big pieces too, but we got it done. And I always try to share some of those techniques with you, you know, whenever I'm doing my lathe work or my mill work. The metric threading technique that I was sharing with you, I've talked about in several different videos. I don't remember if I have a dedicated video just on that subject. That's something that I thought about that I should make, is make one for metric threading and disengaging the half nuts there. But hopefully you guys picked up on that little tip right there, and maybe that'll help you out too. So this job is done. I'll let Paul know, see about getting all this packaged up carefully. He did a really good job packaging this so that it did not get damaged. A lot of insulation in the box, cardboard insulated, and he even insulated this really well too, so we got to make sure that we get it packaged up really well. So before we let you go, there's one more thing that I want to do for you. Let's see if I can do this for you.